Hi. Welcome to ExHAC. In this example, we have an outdoor liquid propane tank with a stream temperature of 40 degrees Celsius and a pressure of 1,200 kilopascals. Liquid propane is an interesting substance because it is a gas liquefied under pressure. A propane release will often cause ice to form around the release source due to a thermodynamic cooling effect that causes water vapor in the air to condense and freeze around the release source. Since propane is heavier than air, it will collect near the ground, creating a flammable layer, thus affecting the classification extents. The most likely source of release from the tank are the valve stem connections we see here. Let's use ExHAC to classify this propane tank. To start the hazardous area classification, we first need to define the project. We will assign the project number as example 2 and name and describe it as a propane tank application. The site altitude is 500 meters. The minimum ambient temperature is -10 degrees Celsius. And the maximum ambient temperature is 40 degrees Celsius. The location is a tank farm. The user project description is Tank Farm Classification Update. Click Submit and the project will appear in the project list. Next, we select the compounds involved in the release, which is propane in this example. Propane is already listed under generic compounds, so you won't need to create a custom compound. Now we go to FM tab, we see that propane is not listed in the generic flammable mixtures section. Therefore, we need to configure a new flammable mixture for propane. This is necessary so that we can incorporate the flammable mixture into the HAC module for analysis later on. Click on Create New Flammable Mixture. Now we enter the mole percent of propane, which is 100% in this case since this is a pure propane mixture. Click Save, and propane will appear in the Custom Mixtures section of the Flammable Mixtures screen. In the FM Analysis tab, propane is not listed, so we need to create a new FM analysis. Click on Add New FMA, find the propane mixture under this list, select it, and click on Start Analysis. The properties of the propane mixture will appear in the next window. The analysis will be automatically saved for you so the next time you require propane in a HAC analysis, there will be no need to configure propane as a flammable fluid. Now, we need to create the source of release. In this example, the most probable source of release are the valve connections on the tank. We will name this as a propane tank valve release. Upon release into the atmosphere, propane turns from a liquid into a gas, so we select a liquefied gas release. Let's assume that the stream temperature is running at 40 degrees Celsius. For the stream pressure, propane tanks typically have pressures between 700 and 1,400 kilopascals to ensure the gas stays in a liquid state, so we will define the pressure in the tank as 1,200 kilopascals. The grade of release will be secondary as the release was not expected to occur during normal operation, and will only last for a short period of time. We will define the ambient temperature of the release as 20 degrees Celsius. Press Submit and the SOR will appear in the SOR list. Since this tank is located outside in a freely ventilated location, we do not need to create a new enclosure. We can go direct to the HAC analysis. Now we start the analysis. Click Create HAC. Select Example 2. Propane FMA. Propane tank valve release as the SOR. And non-enclosed. Click Configure Analysis. Let's review the HAC default analysis parameters, and override any parameters if needed. For the type of release, we will expect propane to create a heavy gas release, close to the ground. We will enter this in the override cell. We will leave the wind speed as 0.3 meters per second for this reason. To determine the hole size, we look at Table B1. The valve connections are sealing elements on moving parts at low speed. Given that the tank has been in service for many years, and some of the valve connections appear to be corroded, we will use a larger hole size to account for the operating conditions. The larger hole size will give us a more conservative result. Based on the table, a hole size of 2.5 mm is selected, so we will input 2.5 here. We will leave the saturated vapor field as false, as we expect the release to be in a vapor state. The polytropic value and stream compressibility values have been provided from the FM analysis module, so we will accept these values. The availability of ventilation will be good, as it is a non-congested area where the leak will likely occur. The remaining parameters are set to NA, and are not required for the analysis. Press Start Analysis. Let's review the results in the HAC Output tab. Our analysis indicates that a Zone 2 classification surrounds the source of release, with a vertical extent of 2.39 meters, and a horizontal extent of 5 meters. The extent of classification is based on the diffusive curve for the vertical extent, and the heavy gas curve for the horizontal extent, as we see on the chart. If we are satisfied with the results, we can press Save Analysis to store our results. To create a report, go to the HAC tab. Select the HAC Analysis list. Select Create Report for our project. A complete summary of analysis is displayed. To save the report, click Save Report. To create an Excel version of the report, click on the Export to Excel Report tab. You can then use the results to create your hazardous area classification diagram. The hazard zone surrounding our propane release will look like this. R1 will be the vertical hazard extent. R2 will be the horizontal extent. R3 is an engineering judgment call. And 1 meter is often used as a default value, based on guidance provided in API, and other recommended practices. The H value is a function of the elevation of the source of release, and will vary with each application. If we apply this diagram to our propane tank, the classification will look something like this. The group classification and the auto-ignition temperature are described in Part 1 of the IEC format tabular report. The zone classification and extents are defined in Part 2 of the IEC report. Applying this information to a plot plan or cross-sectional area drawing will help to convey the classification design to users who need the information to make explosion safety-related decisions. Our hazardous area classification design for this propane tank application is now complete.